In this example, we're going to continue to multiply decimals, but now we're going to look where one is a decimal that is greater than 1, and the other number is going to be either a whole number or a decimal. So rewrite the multiplication statements using copies of language and word names, then represent the decimal problems using the decimal grids. So here we have 3 times 1.2, or 3 times 1 2/10. So we will write 3 copies of 1 2/10. So let's see what this would look like. So notice there's 6 grids here, so I'm going to write my first copy of 1 2/10 here, the second copy, and the third copy. Now, first I'm going to do 1. Just going to make this dark blue, and I'm not going to shade it perfectly because that might take forever. So this is going to be 1, and now I'll do the 2/10 in orange. So that entire grid up there is shaded, representing 1, and there is our 2/10. So this is 1 copy of 2/10. Now I'm going to fill in the rest. I'm going to do the 2/10 first, since I have my orange pen ready. And now I'm going to fill in the 1 of the 1 2/10. So I paused to spare you the tedium of me shading these in. So now we have 1 2/10. This is our first copy, our second copy, and our third copy. So the product is the cumulative amount of all of these. So we have 3 1s here, and here we have 2 4 6/10. So combining these would be 3 6/10. So 3.6. Notice, if we look at the 1.2, but ignore the decimal for a second, 3 times 12 is 36. So notice this is a version of 36 with the decimal in another place. We have 36/10 in this case. We could think of this as 10/10, 20/10, 30/10, 32, 34, 36/10. Let's look at another example. Now we have 3/10 of a copy of 1 2/10. So let's write that language. 3/10 of a copy of 1 2/10. Okay, there's a ghost erasing my work. There we go. So we're going to start by making a copy of 1 2/10, and then we're going to take 3/10 of that. So 1 2/10, I'm going to shade them pink, would be 1 entire decimal grid, and then we need 2/10 from the next decimal grid. So there's 1 2/10. Okay. So again, for the purpose of this problem, we'll think of this as the vertical columns. This is 10 columns. 10/10 is 1. 2/10 is that 2/10, or we have a total of 12/10. Now we're going to take 3/10 of a copy. So now I'm going to think of the horizontal, and we would go up 3 rows to find 3/10. So now I'm going to get the light blue highlighter. I'll start here. 3/10. And I also need to do this in this grid. And 3/10. And the region that's shaded dark blue is going to be our 3/10 of the 1.2. So let's see what this equals. Well, this is 3 times 10, so this is 30 hundredths. We have here, or you could think of that as 3 tenths, either way. We're going to adjust it later to write it as a decimal, and here we have 6 hundredths. So our total is 36 hundredths. Okay, so our product is going to be 0.36, 36 hundredths. Okay, so here, notice if we ignore the decimals, 3 times 12 is 36, so we're going to have 36 of something, okay? And the unit fraction depends on where these decimals are, okay? So, notice there was one spot to the right of the decimal here and here, so that's a total of 2 places after the decimal. And we have 2 places, numbers, digits, after the decimal here as well. And that's not a coincidence. This is going to be our pattern, just like we saw in the other problems. So, based on the last 2 problems, what do you think 0.03 times 1.2 equals? Explain. So this is 3 hundredths times 1.2. So let's put our results from the previous slide. We saw that 3 times 1.2 was 3.6. In this last problem, we saw 0.3 times 1.2 was 0.36. Okay, and now we're asked, what would 0.03 times 1.2 be equal to? Okay, so 3 copies of 1.2 is 3.6. 3/10ths of a copy of 1.2 is 36 hundredths. So 3 hundredths of a copy of 1.2, well, that would be 1/10 the size of the previous result. So notice here, to go from here to here, we move the decimal point over 1. So if we change this decimal by 1 more place value, we need to change this one by 1 more place value. Let me change the color. So we'd move this over 1 and we'd have 0.036, or 36 thousandths. Okay, so we take 3 hundredths of a copy of 1.2 and it would give us 3 hundredths and 6 thousandths. Okay, we're going to summarize these results in the next slide and then use these patterns to multiply more quickly without writing the grids.